Hey, what's up? It's Triggy, and today we'll be controlling a pneumatic cylinder with an Arduino. The whole point of robots is that they move. The most typical source of movement comes from motors, which convert electrical energy to rotational motion. Sometimes we want to move linearly though, instead of spinning. A common solution is to use a linear actuator, which, by the way, is actually just a motor spinning an Acme rod, and like motors, linear actuators can be made very precise and can be powered electrically. The trouble is they're not all that powerful, meaning they're not really that fast and not really that forceful. You can trade off force for speed and vice versa, but you're still very much limited by the overall power output. So, for cases where you need speed and power and not so much fine precision control, consider pneumatic cylinders for your project. A quick refresher on pneumatic cylinders. Here's a cross-section of a cylinder. When air is applied to the left input, the cylinder rod is forced to extend. When air is applied to the right input, the rod is forced to retract. We can control the flow of air into the cylinder with a 5-2 control valve. It takes a single stream of air as an input and controls the airflow through the two outputs. It also has two exhaust outputs to control the flow speed of the air out of the cylinder and thereby the speed of the rod. Here we'll add some Teflon tape to quick connect fittings. A fun fact about building stuff in the US is that not only do you have to be comfortable with both metric and imperial units, you also need to buy whack parts to convert between them. For example, the threads here are 1/4 to match the air compressor, while the input for the tube is 6mm to match the cylinder. Now that we have all the connectors and exhausts attached, we can look into how the airflow is controlled. The electrical terminals are tucked away in here, so we can unscrew the sections to access them. When we apply 12 volts to the terminals, a solenoid activates and air flows through one of the two outputs. Let's call it output 1. This makes the cylinder rod extend. When no voltage is applied, the solenoid is not active and air flows through output 2, and the rod retracts. So all we have to do is apply and not apply 12 volts to the valve to control the cylinder. Here we can hear the solenoid clicking when I attach and detach the battery. Let's cut some 6mm tubing to connect our input to the control valve, and the valve outputs to the cylinder inputs. Now we can power up our air compressor and connect it to our system. We haven't worked out any of the electrical stuff yet, but the control valve has a test button which we can use instead of the solenoid to activate the cylinder. And it looks like everything's working so far. But we don't want to have to press this button constantly, we want to control the cylinder with a microcontroller like an Arduino. To do that, we'll use a transistor. This one is an FQP30N06L MOSFET. This will act as a switch that we can control with a 5-volt signal. If we apply 5 volts to the gate pin of the MOSFET, we allow current to flow. We'll power one side of the breadboard to 5 volts with the Arduino's 5-volt and ground pins. We'll then attach cables to the other half of the breadboard, which will later connect to a 12-volt power source. We'll also tie the grounds together. We'll then connect a signal wire between the gate of the MOSFET and one of the digital output pins of the Arduino, let's say pin 5. We'll add a pull-down resistor to the gate, then add indicator LEDs to the 12-volt source, the 5-volt source, and the gate. This will help us keep track of what our circuit is doing in action. We'll then connect output cables between the 12-volt rail and the MOSFET drain pin. This is the output and will connect to the control valve solenoid. And that's it! The 12-volt indicator LED turns on when we connect 12 volts, and likewise a 5-volt indicator LED turns on when we connect 5 volts. Let's write a super simple script to control the behavior of the cylinder. We'll assign our signal pin to be pin 5, declare it as an output pin, and then alternate between setting the pin high and low with a 1-second pause in between. Let's connect the battery, the Arduino, and the solenoid to the circuit. If we touch the signal pin to the 5-volt rail, we see the blue LED turns on and the solenoid activates. If we connect the signal wire to our output pin, the LED and solenoid activate at a steady rhythm. Let's attach the cylinder, connect the pressurized air, and connect the signal pin to our output pin. We see our cylinder extends and retracts exactly as we specified in the code. And now we have successfully controlled the behavior of a pneumatic piston with an Arduino. Fun! That's it for this video, thanks for watching. If you enjoy this kind of content, be sure to subscribe, and I hope you liked the video.